Throughout our lives, we've seen time as a straight line, the past becoming memories, the present fleeting, and the future a mystery waiting to happen. But there's more to it. Underneath this simple idea lies something complex and fascinating. Past, present, and future existing all at once. How we see time affects how we understand life. Lately, scientists diving into physics uncovered something mind-blowing. It questions everything we know about time. This discovery shakes the core of how we think time works. Before we go, please take a second to subscribe to our channel so you won't miss our future videos. The experiment conducted in 1971 involved flying an atomic clock around the globe and comparing its readings with a stationary one on the ground. As predicted by Einstein, these clocks diverged, differing by a mere few hundred billionths of a second, providing tangible evidence that emotions can influence the passage of time. This validation reaffirmed Einstein's theories.
Einstein's theory has been tested again and again and again, and it all hangs together. It really forms the basis for the way we understand much of the way nature works.
These effects, which used to be considered sort of obscure and very small, are very in your face with today's technology.
However, the evolution of technology has unveiled an unforeseen correlation between space and time, prompting Einstein to dismiss their separation. Instead, he conceived the fusion of space and time, coining the term space-time to encapsulate this four-dimensional amalgamation.
Einstein unified the idea of space with the idea of time into this four-dimensional structure called space-time.
The apparent disparity between past, present, and future might be an elaborate illusion. In our daily lives, time seems continuous, yet it's also akin to an intricate series of snapshots or moments. Envisioning every single moment in the universe aligned, each earthly instant, every orbit around the sun, and each universal occurrence would reveal an exhaustive visual narrative encompassing all events past, present, and future across every corner of space and time. From the very start of our universe exploding into existence around 14 billion years ago to stars forming in our Milky Way galaxy, and way back to when our planet Earth first took shape about 4.5 billion years ago. This is the big story of time. It doesn't stop there. Time keeps moving, watching dinosaurs roaming the Earth, civilizations rising and falling, and even right up to this moment, like me thinking about space-time while working in my office. Now, think about what now means. It's like a snapshot of everything happening at this very moment. For example, the clock striking noon, a cat jumping from a window, a bird flying in a faraway city, a meteor hitting the moon, or a star exploding in the sky, all happening at the same time but in different parts of the universe. These events, even though they're happening far apart, all fit into this thing we call now. It's like they're all on the same page of a giant book called Space-Time. This now page holds everything that's happening across the universe, changing the way we see this moment in the big story of time. Common sense would say that you and I and everyone else will agree on what's happening or what exists right now, moment after moment. That is, we would all agree on what lies in a given now slice. But Einstein showed that strangely, when you take motion into account, this common sense picture of time goes out the window. You see what I mean? Think of space-time as a loaf of bread.
Einstein realized that just as there are different ways to cut a loaf of bread into individual slices, there are different ways to cut space-time into individual now slices. That is, because motion affects the passage of time, someone who's moving will have a different conception of what's happening right now. And so they'll cut the loaf into different now slices. Their slices will be at a different angle.
That person who's moving will tilt the knife, will be carving out these slices at a different angle. They won't be parallel to my slices of time.
To get a feel for the bizarre effect this can have, imagine an alien here in a galaxy 10 billion light years from Earth, and way over there on Earth, the guy at the gas station. Now, if the two are sitting still, not moving in relation to one another, their clocks tick off time at the same rate, and so they share the same now slices, which cut straight across the loaf. But watch what happens if the alien hops on his bike and rides directly away from Earth. Since motion slows the passage of time, their clocks will no longer tick off time at the same rate. And if their clocks no longer agree, their now slices will no longer agree either. The alien's now slice cuts through the loaf differently. It's angled toward the past.
Since the alien is biking at a leisurely pace, his slice is angled to the past by only a minuscule amount. But across such a vast distance, that tiny angle results in a huge difference in time.
So, what the alien would find on his angled now slice, what he considers is happening right now on Earth, no longer includes our friend at the gas station, or even 40 years earlier when our friend was a baby. Amazingly, the alien's now slice has swept back through 200 years of Earth history and now includes events that we consider part of the distant past, like Beethoven finishing the Fifth Symphony.
We can have actually tremendous disagreements on our labeling of now, what happens at the same time, if we're spread out far enough in space.
And if that's not strange enough, the direction you move makes a difference too. Watch what happens when the alien turns around and bikes toward Earth. The alien's new now slice is angled toward the future. And so it includes events that won't happen on Earth for 200 years. Perhaps our friend's great-great-great-granddaughter teleporting from Paris to New York. Once we know that your now can be what I consider the past, or your now can be what I consider the future, and your now is every bit as valid as my now, then we learn that the past must be real. The future must be real. They could be your now. That means past, present, future, all equally real.
If you believe the laws of physics, there's just as much reality to the future and the past as there is to the present moment.
The past is not gone, and the future isn't non-existent. Past, the future, and the present are all existing in exactly the same way.
Just as we think of all of space as being out there, we should think of all of time as being out there too.
Einstein's groundbreaking revelation disrupted our fundamental perception of time, dismantling the conventional boundaries between past, present, and future. He boldly claimed that this distinction, so deeply ingrained in our experience, is merely an illusion, though persistently believed. Your support means a lot. If you enjoyed this content, don't hesitate to show it by hitting the like button and subscribing. Thank you for watching, everyone. Stay tuned for the next intriguing video exploration. See you soon.